Welcome folks, we are ready to start the second tutorial for learning the Cadence IC tools. As we stated in the previous tutorial, that we are designing this tutorial for junior year Electronics 1 students, and we're gonna ramp up from very simple circuits to the ones that are related to traditional Electronics 1 material. So we will start by first loading the NX client, which is a client that runs on Windows that will connect to the Linux server that we have to run the Virtu software, which is one of the Cadence IC tools. So we're gonna come to the start menu and we're gonna click on NX client for Windows, and by doing that now we are ready to log in. So I'm gonna log in and you're gonna enter the passwords to log in. So here is my password. And I'm logging into my system. Now my login time is very fast because I'm recording this tutorial from my office, which is directly connected to the LAN network connection that is connected to the server in the same building. So my connection is a little bit fast. If you are a student of ours and you are connecting to the same server from home, for example, it might take you some time. Not too long, maybe around anywhere from 5 to 10 seconds, depending on your speed and your modem speed. But in any case, I was able to connect much faster than the ones who gonna connect from home. Now I wanted to start a shell or a command window or a terminal. So to do that, I'm gonna come anywhere in this Linux client environment and I'm going to right click on my mouse. By right clicking, I have different options, and I'm gonna select open in terminal. By opening a new terminal, that's what I have. And now I'm going to move to the Cadence directory that I have created early on from the previous tutorial. So I'm gonna do CD, stands for change directory, and then I'm gonna use the delt, stands for the home or the root directory of my home directory. And then I'm gonna go to a class, then backslash, I'm gonna do EE311, that is the course number, and then I'm gonna write Cadence. Now keep in mind that this particular directory that's shown here is that a directory I have created, and I set up the environment to make sure that I can run Cadence from this directory, as we showed you in the first tutorial. Now I'm going to hit enter. So I have already moved into this directory, and now I'm ready to run the Virtu software. So I'm gonna write Virtu, and then I'm gonna have the and sign here. So Virtu, I think I'm missing an R, Virtu, okay, and I run it. So now it's gonna run my Virtu software. Again, my software was able to be run very fast as shown here because I'm directly connected to the server through the LAN network in the same building. In any case, this is my Virtu interface, window interface. And now the first thing I'm gonna do is I'm gonna create a new library where this part, homework 2, gonna have its own dedicated library. So I'm gonna go to file, and then I'm gonna select new, and I'm gonna use library. Now keep in mind that libraries are the basic mindsets of IC designers. And the reason is that ICs are complex systems, and the way we design our modules and parts is by making them as libraries, and then we can reuse those libraries as we want it. Now inside those libraries there are smaller modules that we can use and design and modify, or we can port it from other libraries. We call them cell views. So here I'm going to select a library just to show you that we can use libraries. And now I'm going to give the library a name. So we're going to call it homework 2. You can call it any name if you want it. And this particular library, I'm going to use the option for it to be reference to existing technology. Reference to existing technology libraries, which basically means that I can use the content of other existing libraries. So those libraries can be provided to us by other companies that we purchase, or other vendors, or we can design them if we want it, and we can build them. In any case, in this one I'm going to use reference to existing libraries, and I'm going to click on apply. And now when I do that, it will say which of those list of libraries that I'm going to have to reference. Because this is a very basic assignment, all what I am going to reference is basically the analog library. So I'm going to click on the analog library, and I'm going to say move to the right column. The right column says that this is the reference technology libraries that I will use. I will only use one. You can add all of them if you want it, but I will keep it as one. I'll click OK, and here we will say OK. I already added it, so I'm gonna hit close, and then that's it. The library have been created. Now what am I gonna do is I'm gonna create the first circuit in this tutorial. So what I'm gonna do is I'm gonna go back to new, and I'm gonna select cell view. That basically means that I'm going to design a new circuit or a new cell, that this particular circuit can be used over and over again if I want it, which we are not going to do here. But basically, to design the circuit, it is going to be a cell. This is the mindset the IC designers use, so that they can use something we call top down design. Basically, you're looking at the system from the top, and you can design it all the way to the bottom. And you can also use bottom up design. When you design small cells and you want to build a bigger modules, we call them bottom up design. Or you can use top down design, where you can design the entire system from scratch, and then you come down and you implement it in smaller modules. In any case, we're going to create a cell here. So we're going to call this particular cell voltage divider 1. Voltage divider 1, and the view going to be schematic. Schematic means that we're going to draw the circuit. Now the application is something that is interesting. We're going to add here something that is called ADEL. Basically, we're going to run a simulation using ADEL. So we're going to click on that, and for us, we're going to use mostly schematics and simulations in this particular course. So you can select this one. Always use this application for this type of files. That's good enough for us. You don't have to, but you can always say that, which means that next time you create a new file, it's going to give you the ADEL option. You don't have to redo it. But in any case, now you're going to click on OK, and it is ready to load for us the different windows. The most important window for us is this one, where we call it the analog design environment, ADEL. So the analog design environment is basically what we're going to use, and that's what we're going to have here, and that's where we're going to draw the circuit. So in order for us to draw the circuit, we're going to look at some of the options in the menus. The thing here is you're going to have save, check, and there's save here. So when you save, check basically means that save the content and check if I haven't made any rules mistakes, like if I don't have some resistors not connected or a floating node or something, then it will show me an error here. So this is important. When you save the circuit, is going to check. If you know that you haven't finished all the drawings, you can just save it here, which we don't have options. Here you have something called the create instance. Basically, those are components or instances that you can port. Those are the wires you can use. And this is a pin. You can create a pin, like input pin or output pin and so forth, which can communicate with other cells. So the pin is important in later on designs, where if you wanted to interface your cell with another cell, if you wanted to combine what you designed in this cell with other cells, and the other cells will not see what's the content of this cell, all what it will see is the pin, which is the I/O pin, what's the input and what's the output of that cell. So again, this is like a little bit advanced for people who design system level architectures. And over here you have the simulator, which is the Spectre simulator that we have. So you can decide what kind of analysis you're going to have. For this particular tool, we're going to use DC analysis. We're going to talk about it shortly. And then here you're going to set up the outputs, and that's to run the simulation. So here you define what's the simulation going to be. We're going to use DC simulation in this particular tutorial. Over here, we're going to define what's the output's going to be, and that's how you're going to run it. So you wanted to draw the circuit. That's the objective over here, is how are we going to draw the circuit. So the first thing you do is you're going to come to this icon where it says create instant. Create instance, and you click on it. And to create instance, the easiest way to do it, if you aren't familiar with your library, is to go to browse. So you click browse, and over here it's going to give you a long list of libraries you're going to have. I'm going to click on the analog, and I'm going to when it comes to this particular column, the cell, what am I going to port? So I'm going to say I'm going to port VDC. That stands for voltage source. You already have it in the list here. And the view, I'm going to select basically symbol. It's going to show me the symbol. If I move to the environment here on the grid, you can see that I have the symbol of the voltage source, right? Because it shows me that I'm going to use the symbol. That's all what I need. So I'm going to click once here, and then I'm going to click on escape to make the other windows disappear. Now I'm going to come to this element, the voltage source. I'm going to right click on it, and I'm going to see properties. I'm going to click on properties, and now yeah, so if I double click on it, here is the properties I have, and I'm going to let's see if I can do it with this one. Q, here you go. Okay, so I double click, let's go back again. So you click on it, you right click on it, and you click on properties, and then by doing that, that's what I have here. And all what I need to do is basically add a value for this voltage source, and I'm gonna add a 1 volt. So I'm gonna add a 1 volt. The rest of the parameters I don't care for. So it says, would you like to add noise to this voltage source? No, I won't. Usually noise is covered in senior year and grad level courses, or they are basically used by experienced engineers. Noise is very important part in analog design and also in digital design, or in basically both analog and digital designers, and especially IC designers. But for this introductory level, we will ignore the noise, so we will not introduce noise to this particular voltage source. I'm not going to add any AC components to it, or am I going to have any phase to it or anything. All what I need is just a pure DC voltage source. That's what I'm going to have, and I'm going to add a value of 1 to it. I'm going to do apply. You can see that it added the units as a voltage. We're going to say OK. So that's all what I have added, is basically voltage source, and now I'm ready to add the two resistors to use a voltage divider circuit. So here I'm gonna go back and click on instant again like I did. Now I'm gonna be under the library. If I wanted to see more, I would add on browse, and here I'm gonna use a resistor. So under the cell we're gonna write res starts for resistor, and I need two resistors, one gonna be vertical and the other one gonna be horizontal. So I'm gonna close this one, and now here is my properties that I'm gonna add. So I'm gonna rotate it once, so it's gonna be rotated this way, and then I wanted to make the value of this one 1 kilo ohm. It's already defaulted as 1 kilo ohm, and I'm gonna put this resistor over here, and that's all what I need to do for this resistor. Now I wanted to rotate the second resistor to have it in parallel, so I'm gonna click on get instant again. Hit escape. Then I'm gonna put click on instant, get instant again, get instance again, and now I'm gonna have a resistor, but this resistor gonna be 4K, and now I'm gonna do a rotate. So one more rotate, so one more, okay. So now we have this resistor, and I'm gonna have this resistor connected over here, and I'm gonna hit escape, and now I'm gonna hit another escape, and I'm going to wire those resistors to the voltage sources. So I'm gonna come to this node. Let's hit this icon to do a wire, and now I'm going to connect this resistor to that resistor, this voltage source to this resistor. Now keep in mind, if you couldn't do the wire, go back and click here, and then hit the escape key, and that will do it for you also. So we're gonna do the same thing here. We're gonna connect this to that, and then what I need is two more things. I want to add a pin. So here is a pin. I'm gonna add a pin. Let's show you one more time. This is a pin. So I'm gonna add or create a pin. So I'm gonna give the pin name to be V out, basically to show you that is the output. The direction gonna be output. So this pin gonna be an output, and that's all what I need. So I'm gonna come in and place the pin over here, and then I'm gonna hit escape, 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 and then I'm gonna go back to the node, and I'm gonna connect this one like that. So now the output is basically connected across the second resistor, and now the only thing left for us here is to add the ground. So I'm gonna go to library, and I'm gonna come here to the cell, and I'm gonna say GND. GND stands for ground, and so that's all what I have. I'm gonna move it over here. I'm gonna connect the ground to this pin and to this pin, and that's it. So now I have a ground here, ground here. This is my voltage divider circuit. Let's see if I can move it just to make it look nicer like that. You can also connect a line from here to here and use one ground if you want it. Either way, whatever makes you comfortable. So this is basically the circuit that we have. So I'm gonna first of all save it. So it did save. Now I'm gonna save and check rules. So I'm gonna save and check rules, and we're gonna come here. It says in this particular window where it says the CDS log, it says that schematic check completed with no errors, and then it was saved. So voltage divider 1 schematic saved. So it says that there is no errors in the wirings and the diagrams and all that. The net list basically is correct, and it have been saved. So the next thing we're gonna do is basically we are going to set the DC analysis for this circuit to do DC analysis. And what basically we're going to do with the DC analysis is that we are going to sweep, or basically means vary or change. We are going to sweep the value of this voltage source from negative 10 volts to 10 volts. And we would like to see what's the output of the voltage across the second resistor is, or basically what's V out is. So the first thing we're going to do is we wanted to define the kind of analysis we're going to have. So to do that, I'm going to come to this icon where it says choose analysis. So I'm going to do that, click on here, and I'm going to select a DC analysis. So I'm going to come here and say DC analysis, and I don't need to save the operating point because this is a simple circuit. If you have transistors and all that, you can save the operating points to make it faster for you to resimulate the same circuit if you want it. This is not important for us. What's important here is what we are going to sweep. What variable are we going to sweep? The word sweep means vary. So you're going to assume that all what we're going to vary here is basically the DC voltage source. Different kind of analysis you can vary. For example, the value of this resistor. You can say that if this is 1 volt and this is 1K, what's the output voltage will be if the resistor or this resistor will vary from, let's say, 100 ohms to 10,000 ohms. You know, so you can vary different parameters, right, and different components. So what we're going to vary here is basically the input voltage. So I'm going to say that it's a component parameter because the component is basically this voltage source. And now it says select component. So I'm going to select this component. And now it tells me that what parameter am I going to vary. So I'm going to click on DC. And I'm going to choose OK. So you can see that the screen has disappeared. If you click on it one more time, it will pop up again, right? So it became back to the front, and it have filled in the information for me. I use DC analysis. It is a component parameter. I'm going to choose the component name V0, which is this one. And then the parameter we're going to vary going to be the DC value. Basically, it's the DC voltage. We have to define the start and the stop. So we're going to say that the simulation going to start from negative 10. Let's see if this will do it. And then it's going to stop at positive 10. So we're going to say 10. And now the sweep type, I'm going to select linear. And the step size is going to be 0.1 volt. So what that basically means is that the simulation going to start by applying the voltage to be here negative 10 volt. And then in the next step, I'm gonna add a 0.1 volt. So that's going to be negative 9.9. And then in the next simulation, it's going to be negative 9.8 because I'm going to add another 0.1. And you keep adding 0.1 volts all the way until you hit the 10 volts, and then the simulation stops. That's basically what it means. That's all what we have here. You want to make sure that the simulation is enabled. What that means is when I'm going to hit the run, it's going to run the DC simulation, right? So we're going to say apply, okay. So now we define the simulation. Now I have to define or set up the output variables that needed to be plotted. All what I'm going to plot here is basically the voltage at the V out. So I'm going to click on this icon. It says set up outputs. By clicking here, now it will tell me that what am I going to plot. So I'm going to come here and I'm going to say from schematic. And I'm going to click on this element. So it already automatically says that's V out, and it defined it as V out, and it gave it over here the green color. That basically means that the probe, when we probe or when we plot, the output voltage is going to be green. To see it again, to see the window again, I'm going to click on the same icon here. So it did pop up. What's interesting here is you're going to see that in this window, it had added this one. So if you click on it, you can see that it's gonna plot V out, and the type of the plot gonna be a voltage, and when it runs the simulation, it's gonna be plotted. You can save it if you want it, but it's not important for me, but because we just wanted to show you the plot, but you can save it if you want it. And that's it. That's all what we're gonna have. So we're gonna apply, and we're gonna click OK. Now you are ready for the simulation. And to run the simulation, basically we're gonna come to this icon, and in this icon we're gonna hit this icon basically means run simulation. And to do that, it's gonna run the simulation. The simulation gonna run. This is a simple circuit with a simple simulation. We should be able to run the simulation quick. And so the simulation run, and here you go, that we have the plot of V out versus VI. So let's look at the plot carefully. I'm gonna expand it here and make it full screen. So you can see this is V out and this is VI, right? So the gain of the circuit basically gonna be 0.8 because it's a voltage divider. So when the voltage is -10, you're gonna have V out to be -8. When the voltage is -5, it's gonna be here -4, more or less, as you can see here, -4. And when it is 0, when VI is 0, you're gonna have V out is also 0. And when you are 10, it's gonna give you 8 volts. So as you can see, that this is basically the plot of V out versus VI. Now designers need to interpret this data carefully. When they design ICs or when they design circuits, they want to make sure that the output voltage matches what's the input voltage is for a given circuit. Otherwise your design is not working properly and it needs to be retuned. So this is basically the end of the simulation, and now all what I have to do is I need to save it one more time. So we're going to close that. You save and you check. That's it. Basically the circuit is saved, and you have learned how to do the DC analysis for this particular circuit very easily.